let's talk about explainable AI. Thanks for fixing the issue. So I guess I will start with, again, a short introduction of myself. So my name is Andrey Sharapov. I'm a senior data scientist at the company called Schwarz IT. So for those of you who live in North America and not in Europe, let me say that you probably don't know this brand, the Schwarz Group. In Europe, it's very well known. So Schwarz Group is basically a very large retail recycling company where we have brands like Lidl and Kaufland. They exist all over Europe, but well, not that much outside, right? So it's a third or fourth biggest retailer in the world. So if you think about Schwarz Group, so things like Walmart, or not Amazon, of course, but Walmart should probably pop up in your mind. So this is the place where I work, and I work on projects related to mostly prediction of demand, marketing, and so on and so on. But today I would like to talk to you about explainable AI. And as I mentioned, I've been kind of working in this field for quite some time already and tracking the field. And today I would like to simply share my knowledge with you, right? And how it applies, let's say, in retail. So we're going to talk about 5 different aspects. I want to mention first, what is explainable AI and why we need that? Maybe many of you already know the topic, but I will mention a few points here. Then I'll talk about emerging approaches, especially for tabular data. And then we'll move on to discuss a retail use case, the one that I've worked a bit in the past. Then I'll talk a bit about software and deployment, how we can use all these methods and deploy them to production. And then maybe a few words about the future. So moving on, basically the buzz around explainable AI started around 2016 or 15. And back then, you could just see articles and, let's say, Wall Street Journal or other papers, newspapers appearing and talking about explainable AI, opaque decision-making processes done by algorithms, and so on and so forth. So this time coincides somehow with the time when David Gunning at DARPA started an explainable AI project and started funding researchers around the world, well, around the US in this case, kind of promoting the idea that, okay, we need to be able to understand complex algorithms and their decision-making process. So all of these events kind of happened back in 2015, 16, and then from there was like an avalanche and exponential growth of different papers, people discussing explainability, fairness, transparency, and these days it goes into a very, very general topic of AI ethics. So overall, the pressure on the field, right, on this explainable AI topic has been so much that it has appeared on a Gartner chart. And back in 2019, about a year ago, right, it was still a growing field. But in this year, 2020, the explainable AI already jumped over the cliff, kind of, and is now moving down, right? So why? I don't know, hard to explain, right? But there was a lot of progress in that field over the last year, or maybe not just 1 year. And now there's a kind of people are realizing if it's useful or not, or where it can really be applied. So the hype phase is over, right? A few words about explainable AI applications. So they're the very, very wide applications of this field, right? One of them could be, let's say, in criminal justice and things like predictive policing and predictive sentencing. There is one instance that I've shown here where the person for fleeing the police was sentenced to serve about 6 years in prison. So, and in that case, the judge consulted an algorithm. Another case would be, let's say, in for public services, right? And let's say when the government cuts your healthcare services and so on, to try to optimize it, and people become unhappy definitely because they see a cut, and they would like to know why this happened, right? So sometimes it's not fair. Sometimes algorithms don't take into account certain factors that are really present. In banking, definitely, yes, you don't want to have an algorithm give you a loan without someone reviewing it. There was a big case last year when Apple Card appeared, and a few famous people applied for that, and their wives got rejected or got a credit that is a lot less. So Steve Wozniak was one of them, and there was a kind of a thunder of news around that. And again, this opaque decision making and bias and things like that played a big role, right? So overall, like explainable AI can be applied in very, very many fields. Also, let's say hedge funds use it to build explainable trading strategies. And there were some words about, we had this high frequency trading being very popular. It's still very popular, but it kind of left this other fund managers aside that trade on fundamentals, let's say, and explainable AI could help them out kind of to also make a comeback. But anyway, so moving on, explainable AI is very useful when one wants to make a high stake decision, be it for policy making, be it in healthcare or so on, right? Or military applications. So there, it is very hard. Well, one can make a decision or ask an algorithm to make one, but accountability level and pressure is very high usually. Given all of that, right, there was some news back again in 2019 when this federal CDO mentioned that, okay, there were some plans to introduce regulation around the usage of AI. And I think this will become more and more relevant in the coming years. But so far there is some regulation around the data usage in Europe, GDPR, it's called, right? There's probably some in the US as well, but I'm not sure there's any complete framework of how to regulate this stuff. So for those who are interested in the topic, I've prepared a set of books. So surely this is not a complete set of books, but at least the books that I looked at myself. So if anyone is interested, there are books that are kind of high level in a sense that they just give you some story around why and what is going on. And there are more technical books on the right side if you really want to dig deep and understand what's going on. If you're someone who is working for a business and would like to use these things right away, and you don't have, I don't know, a dedicated developer for that, you can go out and try these commercial products. So there are a number of companies, including the big ones like Google and Microsoft, who have put out some services around explainability and interpretability. There is a company, very, very famous one in the US called Fiddler. I think their solution does something around explainable monitoring. But again, I don't know a lot about every single company, so I know there are a bunch of them. And they provide certain services around explainability and so on and so forth. So given all of that, right, so explainable AI, in my view, is very, very hard topic because it involves much, much more than just pure technology, right? So there are a lot of different packages and different software written that is freely available to everyone. And I think there are enough experts who can figure out what to do with that. But the main problem still lies in the area of like, how can this whole thing be kind of married with like the social fabric, with the legal aspects, with ethical issues, and how, for instance, explainability and how AI can really interact with humans, right? So definitely, if we talk about a robot, well, yes, we can say like, okay, a robot can shake your hand and this way it interacts with you. But when you talk about, I don't know, loan prediction or predictive policing, so how can an algorithm explain why it makes a certain decision? This still is an open question, right? How it can effectively interact with you. So given all of that, right? So the area of AI itself is very broad, right? Like I've mentioned, one can do simple regression models, but one can do also computer vision or text analytics, or you name it, something, recommender engines. And the explainability part exists in all of these subfields. But in this today's talk, I would like to only mention tabular data, right? So the data that most businesses work with on a daily basis. So in here, one can split the research in the area of explainable AI into, let's say, 4 subcategories. And if anyone wants to use these methods, right, you should look up maybe according to this structure. But the first one would be glass box models, right? And if you practice at all machine learning or any statistical methods, you would know about linear regression or logistic regression, or maybe decision trees. But additionally, there are a lot of other methods that have appeared in the recent, I don't know, 3-4 years, right? These are rule sets and rule lists. So they generate more or less like a rule for like a decision tree, but it's a bit much more condensed, and the way it's derived is much more robust. There are also association rules, Bayesian networks, etc. Right? There are techniques about model distillation, and in this case, one can try to convert a model to a decision tree or rules, and there are also a number of methodologies that can take, let's say, I know, random forest and transform it into some kind of a rule representation. These are very handy for model debugging and for like general understanding of what your model is actually doing. For model explanations, I would subcategorize it also into global and local. For global ones, visualization techniques are very useful. There are a number of charts developed by researchers. One of them would be like a partial dependency plot. This is the simplest one. There are other plots out there. There are also a bunch of packages that can help you create these plots, right? There are also model agnostic feature importances. So for instance, if you build a model, I don't know, be it a neural network, then given this algorithm, you can generate, let's say, these feature importances that would tell you which features are the most important, right? Let's say if you do something like credit scoring, then maybe a person's I know, salary would play a big role, right? Or maybe a person's, I don't know, age would play a big role, right? But this is a global explanation, right? What is the most interesting here are these post hoc model explanations, right? And these ones give you an explanation of every single decision, right? So if you, I don't know, again, credit scoring example, if your loan is denied, let's say, and then you get a lower score, let's say generated by a model, and then these techniques can show you, okay, you didn't get a loan because, I don't know, your, salary was not high enough. So that there will be a certain feature highlighted that, or maybe a set of features highlighted that would tell you why the algorithm arrived at this decision, right? So it will not arrive, it will not tell you exactly how to improve. There are also techniques that can show how to improve, let's say, how to flip a decision of an algorithm, and we'll talk about this in a later topic, right? Later today. So yeah, like I said, we're going to cover the ones on the post hoc. These are the most exciting stuff in my view. So for those of you who are, I don't know, if you want to quickly try an algorithm, just an interpretable algorithm, right? You can just go to this website at Harvard, or use this, yeah, just to use this website and see, upload your data set and try to run one. And you will get an explainable model that, I don't know, looks like a list of rules. So I think, so this is a very simple stuff, but still you can try it right away. So, okay, so far I've been talking about very general things, right? So the importance of explainable AI, and then I also mentioned all of these algorithms, and definitely if you're not an expert in the field, it's a bit hard to just jump on the train and understand everything. But here I would like to go to a very specific use case that I worked on in the retail industry, right? And I just talk a bit about how explainable AI might be useful in retail industry in general, right? So here on this slide, you can see that there are multiple ways that it can be used, right? First one would be like for stakeholder management. And what usually happens is that when you go out and build a model, or you work on a certain use case, and go out to I don't know, a retailer to show him those results, right? They will not necessarily start trusting your results, right? They would like to see, okay, how the model functions, why it arrived at certain decisions. So maybe they will actually try to convince you to use simple rules because this is what they're accustomed to. And here you have this toolbox of explainable AI methods that can help you convince that retailer to use something more advanced and kind of increase its trust, right? So this is kind of goes to the next one, build user trust. And then definitely it's useful for model debugging and trying to find biases or some weird artifacts in your model. So let's look at a case of promotion planning, right? So what is a promotion, right? If you take a regular store, I don't know, whatever is known to you, you go there, I don't know, probably on a weekly basis, and then you see certain items that appear on promotion. Promotion means their price is reduced. And in order to kind of run these promotions, retail companies hire a bunch of people who are responsible for planning these promotions, right? And over the years, these people, when they plan a promotion, they usually have a set of rules in their mind or in their Excel somewhere that kind of leads their decision-making process, right? So that they don't take into account all sorts of factors out there, definitely. So maybe a 5, 7, no more than that. And their job is to figure out what to put on a promotion, when, under what conditions, and let's say how much, right? So, and important to understand that these people usually think in terms of rules, and they know, like in winter, you would better do promotions of that kind because of that and that factor, and they can name you those factors. So when you go out and offer these people a tool that, let's say, helps them to plan a promotion, right, to predict how much to, let's say, how much quantity they want to order, or what conditions to kind of apply to a promotion, they usually kind of start mistrusting the algorithms, because on one side, these algorithms very often generate some results that are not totally intuitive to them, right? Something that they never tried, but is kind of deemed by the algorithm to be very efficient. And when they see those not intuitive results, they usually kind of say, okay, we have to go back to simple rules, right? this is the very simple answer that you get from them. And the thing is that when I talk to these retailers and I offer them, let's say, I build a complicated machine learning model to predict something about promotions, right? But I also use explainability tools to generate simple rules for every single decision, right? So if I want to place on a promotion, let's say, I don't know, some wine, a model would predict how much to order. Maybe it's too little, and the guy would say, "Oh man, this is not correct." But then I would come up, then I show him a set of rules, and then in his mind he would start reading these rules, and they click in a sense that he kind of can cognitively compare them to what he would have thought himself, and maybe he just discovered something on the line, and this. And especially when you show them rules for decisions that align with their original decision, then this kind of processing helps to, again, build trust, make sure that they think the same way as an algorithm, right? This is very important. That right. So this is kind of the technique that I use, right? You can show different types of kind of explanations. One of them is just rules, and the other ones I would show you in the coming slides. So in this planning, or in this talk, let's focus on a classification problem where we want to just say if a planned promotion is effective or not, right? Let's say the uplift is greater than a certain number, right? And we want to answer certain questions, right? Like we have to plan a new promotion, and the tool should be able to do that, an AI algorithm in the end, and we would like to see how effective it will be and why, right? So why is very important here. So the first technique, the explainable AI technique that appeared in the literature is called LIME. So LIME is like a surrogate model, right? It approximates your decision locally, right? So for every single decision, let's say, again, I want to make a prediction about, again, eggs being on a promotion, right? Something very simple, or something else, doesn't matter. And this LIME technique can tell you, okay, for this particular model, and then for this particular decision about, I don't know, placing eggs on the promotion, why the promotion is effective or not, right? And in this chart, you see that, okay, again, this chart is built upon the data that we used internally, definitely, and the features that were used internally. But let's say the item family is important in this case, and the price difference is also very important, so that he was able to reduce the price of eggs enough to make it appealing to a customer. And then let's say that they wanted to place this promotion on a Sunday or Saturday, let's say, and that played also a very big role, right? So you see those blue bars that move the decision in the positive direction. And then there are some other features, like placing it on a leaflet didn't make any difference. And then let's say the shelf life of a product is also kind of played it down, but we could see here the drivers of a promotion, right? What makes it successful for that particular product, and that for that particular decision. A similar technique is called SHAP, right? These are famous Shapley values, and every single prediction can be broken down into like a sum of contributions. Again, the way that I compute it is beyond this talk, but in this case, you can also generate a similar bar chart where every single decision, right, has a certain, basically has this chart. And in this case, let's say if you want to place coffee on a promotion, right, what features would play a role for that particular decision, right? Here you see price was a driver, item family, month when you want to place that on a weekday, and then the shelf life didn't matter much. Well, because for coffee, probably coffee can be stored for a very long time. Another approach is called Anchor. So Anchor is very nice in the sense that it can generate human readable rules, again, for every single decision, right? Not for the model overall, but for every single decision. And here I just made one. So again, price was the factor, item family, and let's say item placement within the store. Another one that is very interesting, it's called counterfactual explanations. So when I told you this example about you getting, let's say, a negative decision about your a loan at a bank, right? Even if you generate an explanation of a kind like Lime, SHAP, or Anchor, they will not really tell you what is wrong, right? How you can improve. But the generation of a counterfactual explanation can actually show you things that you can actually improve, because a counterfactual is basically the closest example to you that has a flipped decision. So let's say, okay, you got a decision no. What would be the smallest change in your features, your income, I don't know, your age, your whatever, that would flip that decision. And generating such a counterfactual is very useful, because maybe you just need, I don't know, a few thousand more in your salary in order to flip that decision, right? So in this case, in the case of a retailer, how can, let's say, one plan a promotion, and then let's say a retailer plans a promotion, then they put it in the system, and the system says, okay, this promotion is not going to be successful. But if one generates a counterfactual explanation, the system can suggest which features one can change in order to flip that decision. So one may say, okay, maybe we should change the item family for good, like throw it out, take another item, or maybe you just have to change the price of an item, right? And then the decision will be flipped, and the promotion will probably be more successful. And finally, I would like to talk about another one. It's called contrastive explanations. So these are also explanations that look like rules, but they answer a slightly different question. So why P rather than Q? In a sense that I gave you an example. Let's say model predicted 0 instead of 1 because the price was less than a certain number, right? So these are counterfactual why P rather than Q, right? So in general, if you read literature on explainable AI, the majority of methods will fall within the range of those 5 categories, right? There will be these local surrogates like Lime. There are different flavors of Lime out there. There will be Shapley values, also a ton of ways to do Shapley values for different use cases and so on. And a lot of research on counterfactuals. There's also a lot of research on contrastive and also on rule generation. Definitely, there will be maybe another 10-15% of papers where they would come up with some super original idea how to generate an explanation of an algorithm. But like I said, in the majority of cases, there will be just these 5. So for those of you who would like to try some of these things, right, I've prepared a list of GitHub repos, because again, this stuff only exists on the pages of researchers, doesn't exist in any I don't know, products that you can buy or download freely. So for rule lists, something very recent, these are the links. For rule sets, also a number of links for rule generation in general, right? So these slides are actually available in my GitHub. So if anyone is interested, you can just take that. Also for model distillation and for model visualization, a bunch of very interesting packages out there. Right. So, and again, the most interesting stuff that I I like the most. So these are the post hoc explanations like climb, shap, anchor, I don't know, XGBoost explainer, and so on, right? You can just take these GitHub repos and run examples and apply it to your problems. Same for counterfactuals or contrastive explanations and so on, right? And again, for those of you who are really interested in image or text explanations, there are actually very nice libraries. One of them is a XDeep. Another interesting one is called Investigate. So this was done by a German guy here in Berlin. Very nice library again for Keras. I think it's also ported for PyTorch. And for text, the famous one is Captum. It's a library by Facebook. Also, there is something done by Alan NLP and Interpret, and I think there's also something around BERT. But yeah, so I don't use these that much, and if there's interest, I think you can try them and see how they work. So again, as in case of images, you most likely will see certain segments of an image highlighted. In case of text, you will see certain words highlighted, so why they contributed, so what contributed the most, let's say, to a decision. And finally, I would like to mention a little bit about deployment. So when one deploys a model into production, mostly people use things like, I don't know, a Flask server in Python or something else, and then they just serve these decisions. Similarly, one can, of course, serve explanations, but there is a good thing. It's called Seldon Core. It's a library, or again, it's like a framework for Kubernetes that you can use to deploy machine learning models for scoring onto a Kubernetes cluster. And again, the cool thing is that they have an explainer that you can deploy additionally to a model, right? So if anyone is interested, you can just go on the website and read and kind of go through the examples. We don't have time to talk about in detail right now, but if anyone is interested, this is a very good start. So I tried it. It works very nice. And then finally, I would like to ask if anyone is kind of excited about the topic of explainable AI, you can definitely join me on LinkedIn, or you can also join my LinkedIn group called Explainable AI, where I regularly post a lot of content. There are also a lot of researchers there and people interested. If anyone is interested in much more details about this, you can go to my Xscience GitHub repo, and there you will find all sorts of papers and also the slides and code and so on and so forth, right? And then for those of you who are interested in ethics and would like to learn more about, AI use cases and what, let's say, why ethics is important in AI. So you can go to this aiethicist.org, also quite an extensive resource that is quite useful. All right, and then there is the links to paper references. They talk, again, for those of you who are kind of like to have a deep dive. But anyway, so I guess at this time, I would like to thank everyone to be in the session. And if you have any questions, I'm ready to answer them now.